Hello, everybody, and welcome to PyxelChats. I am here today with some lovely guests, my co-host, Carla. Say hello, Carla.
Hello, how's it going?
Great, thank you. And I'm also here together with Richard and Nick. It's a pleasure meeting you, Nick. This is your first time on the podcast. Do you mind introducing yourself a little bit for us?
Hey, Steve. Thanks. I've been working on the blockchain for a little while now. I've been writing smart contracts, and now I'm actually transitioned into writing actual blockchain code. So I'm modifying the Ethereum virtual machine for some proprietary use cases.
That's awesome, Nick. Thank you. And speaking of spoilers, today we will be talking about smart contracts.
All right, let's get into it. Nick, do you mind defining what is a smart contract?
Yeah, for sure. A smart contract is a piece of code that is put onto the blockchain. Most blockchains you'll use for interacting. Like if we look at Bitcoin, it's generally used just for transactional purposes. I send you a Bitcoin, you send me half of a Bitcoin, and it keeps track of all that history and makes sure that everything adds up at the end of the day. But what if you had two people who wanted to actually run a business together, and maybe they wanted all the money to go into one account? And then at the end of the day, they could each withdraw half of the total funds that have gone into that account. That's what a smart contract gives us. It's like programmable money. It gives us the ability for people to interact with each other trustlessly, so they don't have to actually know each other or trust each other, but they can still be guaranteed that they're going to get what they're owed.
That's pretty cool. So what I'm hearing, right, is this is like a middleman that never messes up.
Exactly. It's like the arbitrator between a bunch of people.
I love that. We'll go in a cafe business together, Carla. Don't worry.
Yeah, so essentially it's functions that can run on a distributed system.
Yeah, exactly. That's a great point, Richard, that it's distributed. So it's not like you have one party that you have to trust that's running the blockchain. You have a whole bunch of people that are running it, and they're all validating it. And the smart contract code is just something that somebody programs and is shared between all those people, and all these other people are validating it. So nobody can fake it or come up with like a hack or say that you did something that you didn't actually do.
Thank you. Now we do have the next question. It's, what does this really solve? Richard, please.
Yeah, so there's a lot of use cases for smart contracts. Nick gave a good example of one. The other thing that it solves is the ability to know history of something that has happened on an account in a provable, truthful way, because the blockchain provides that with these smart contracts. It also gives you, like I said before, functionality that just doesn't exist on chain. You can make it to where money can't be withdrawn until a certain amount of time, or you can make it to where multiple people have to agree to do a transaction, or you can make it to where it's kind of reliant on some sort of outside event. Even though the blockchain doesn't natively support this, there are ways to inject information from the outside world as to like what the weather was or what sports team won or something like that, in order to complete some sort of function that sits there and is required.
Awesome, thank you. How do you make one? Like, how does one go about making a smart contract? Nick, do you mind, since I know this is something you do professionally?
Yeah, no problem. So you start by writing code, and code is generally just written in a text editor, and you write out what it is you want to do. And once you have all of the functions that you want, somebody can deposit money maybe, and then after they deposit money, you have a function to withdraw. Let's say we'll just stick with our previous example. In those kinds of cases, you'll add those functions, and then you'll run a compiler. And this compiler converts all that code and all this text that the person wrote into machine code, and that machine code is then sent into the blockchain. And we actually have to pay money to get that uploaded to the blockchain. But once it's there, it can just live on, it stays there forever, and it can execute at any point in the future. And in order to read the data off of that blockchain, it's actually free. So this is how a lot of the dApps and services out in the world work, is they just read the data straight off the blockchain, and that's free for them. It's only when you want to make a state change, like if you wanted to update the balance in one of these smart contracts, that's when you have to pay. So you have to pay, and you're paying the people who run these blockchain nodes, because they have to pay for their electricity and their computer in order to execute the code. And so one of these would be upload my smart contract, and then another one would be update my balance. And both of those operations you'd have to pay for. But like I said, all the reading is pretty much free, and that's how the dApps are all built on top of that.
Awesome. Richard, did you have something you want to add? I have a follow-up question with that too, just out of curiosity.
Yeah, I just wanted to define dApp since we're talking about it. The world is, hearing terms like Web3 and now Web5, and I'm sure other companies soon are going to be coming out with other numbers. But essentially, a dApp is a distributed application. That's the acronym, or well, they basically took the word distributed, took the D off of it, added it to application, and said, hey, this is now some sort of new thing. But really, it's an application that you can't take down, because Ethereum exists in the world, and you can interact with these functions as long as you have enough money and you're allowed to buy the function creator.
That's good. Thank you. I think it's a helpful definition and a very weird acronym of sorts. So really quick for both of you, either of you, whoever wants to answer this, but you were mentioning transactions. How much does it cost, let's say roughly, to create a smart contract?
Well, that's a great question. It actually depends. It's never the same. And so it really depends on how urgently the network is in demand. Ethereum right now can only process 11 transactions a second, approximately on average. And so if the network is really congested and a lot of transactions are coming in, and you actually want this to happen during that congestion time, then you could pay $1,000 plus in order to create a smart contract.
I think during periods of lower activity, like 2 a.m. or something, you can get it for like $500, something like that.
Yeah, I mean, you can actually get it down into like $50, $25 sometimes, depending on how low the network activity is. And Ethereum really isn't doing much to solve this. There are other networks though. There's I think they just changed the name to Binance Network, or is it just BNB Network? I'm not sure. They changed it from Binance Smart Chain, or BSC. And then there's other networks like Avalanche and Solana and some others that allow for smart contract applications.
That are of lower cost, right?
Yeah, typically lower cost, but also probably lower user base, or you have to interact with different, in all of those, you have to interact with their native gas token or native gas coin, which on Ethereum is ETH, or on Ethereum Classic is ETH as well. But on Binance Network, it would be BNB, and Bitcoin has some small smart contract capabilities, but it's a little bit different, and those fees are cheaper too.
So now that we have an idea about how much it would cost, how long does it take to actually make one of these smart contracts?
Yeah,
I'm going to be asking this one for Nick.
Yeah, it really depends on what features are being asked for, and if there's a lot of features that are going into it, then it can take a while. If it's just basic stuff, it can go pretty fast. Fast being, maybe a week to a month. It depends on really what has to be in there, and then testing is where most of the time goes. These smart contracts for programmers are really not that complicated. They're a relatively small chunk of code, but the problem is that they live on forever, and there's financial implications if you introduce a bug. And so, from that perspective, we need to do everything we can to vet it, audit it, and auditing is a good way to go, because they can find known issues, but they're always looking at the constructs of your code, not what your code is supposed to do. And because they are just looking at these very particular ways that the code is written, not what the code is intended to do, you really start to leave open some potential gaps where maybe this code is, audit proof, and it does precisely what it's coded to do, and it's not introducing any known vulnerabilities, yet it's not actually doing what you would intend, what you thought it did, and so there's some potential for problems. So that's where most of our time goes, is in testing. So on a very simple contract, it might take us a week, a day or two to program it, and then 3 days. Sometimes that'll just carry on to another week of testing just to make sure that everything's safe there. But if we get into really complex ones where we're adding complex logic, it can really go up fast. And the reason for that is not so much with the testing side, that's still very important. But what happens in smart contracts is you're really limited in your abilities on blockchain. Everything operates with these numbers that are what we call integers. They don't have good decimal representation. Like we do when on a standard computer, when you're programming, everything can have decimals and you just kind of write the code to do what you want. You don't have to worry so much. But on the blockchain, it's kind of a lower level system where you have to be aware and operate with these variables. And when you're doing really complex math, or you're adding some advanced features like timing of things, you have to think you're on the blockchain. Timing things doesn't work, or triggering things to say, I want this to happen after 10 seconds. You just can't do those kinds of things. So you have to kind of think out of the box. And that's where a lot of the time goes as these get more complex, is how do I handle this with the data structures I have? How do I write this code so that it'll be safe, but yet I can do all these cool features and functions that we intend to, or that our product offering is asking for. And so those can go up to 2 or 3 months sometimes. I think some of the bigger ones, when you're looking at like Uniswap and things like that, those are under development for several months. So it depends on what what needs to be done and what all the requirements are, I'd say.
Yeah, and there's also other nuances with smart contract development as well. I mean, when you're writing a piece of software, you can do all kinds of cool things with it, like schedule tasks and spinning off tasks and asynchronous functions and that kind of thing. Whereas with Solidity and most smart contract languages, you don't get a lot of that capability. If I want a task to kick off at a certain period of time, or I want some event to happen in the future with a smart contract, you can't do that. You can't tell it to do something in the future or to not do something in the future. It's really just when you pay to do a function, it can invoke a function. But every single time you go to write to the blockchain, you have to pay. And then also when Nick is talking about testing, he's talking about writing code that does tests against the smart contract functions that he's created. And oftentimes the reason why it takes so long is that maybe you write 100 lines of blockchain code and then 3,000 lines of test code in order to make sure that you're checking all your functionality in the edge cases so that you don't have attacks or other issues.
Speaking of issues, what are some common security issues that we see with these smart contracts?
Yeah.
Sure. Nick, you first.
There's a lot of different vulnerabilities. I mean, one of the most famous is the DAO hack, and what happened there, it was literally just 2 lines of code. You didn't even have to modify them. You just had to change their order, and the whole DAO hack would have not happened. And hundreds of millions of dollars that were lost. And geez, I don't even know what that is in today's money, and by Ethereum's price today, but it's a huge amount of money. And the reason why that was able to happen is sometimes smart contracts call other smart contracts. And this is where a lot of complexity comes in, is when they're calling into each other. Well, if you call into the wrong contract, like you have one contract call into another one, and that is a attack contract, it can loop back and call yourself, and you can kind of get in this cycle where it can just keep spending money. And the reason why those 2 lines of code were so dangerous is that they didn't update the balance. They updated the balance on the bottom line of code. If they would have updated the balance on the top line of code, that loop of spending all of your money would not have worked, because your balance would have been updated. And in the context that they wrote it, it made perfect sense. It was only when you had this external contract that called back into it that it didn't make sense. So it was very hard to see and very hard to get to. And that's, there's a whole bunch of different cases like this that you can get into if you're, and we have a whole series of checks that we do to make sure that the code is updating the state variables before we do any checks or before we call out to other contracts for these very reasons. Now we have standards. I have a checklist of things that I go through and I look at my contracts to make sure. Every function call in there can be controlled by, let's say that we had something that would pull all the money out of an NFT contract. If we had something like that, I want to make sure that only the owner can do that, right? And so, some of these things can be as simple as just leaving that off, right? Leaving off a check to see if it's the owner. But these are the things that audits can't catch. These are the things that we have to be aware of. So we're in there looking for those. So these are the kinds of hacks that people are out looking for too. So there's a series of different attacks that can happen. A lot of people also talk about like double spend attacks, and if you were to take over the network, and these kinds of things are extremely hard to do. They're very costly. They don't happen nearly. I don't know that you could actually execute some of these in a realistic way, because what happens with like a 51% attack, you have to not only have control of the whole network, but you can't undo history. Even in a 51% attack, nobody could just reach in and take all of your money with a 51% attack. What they can do is they could get a double spend to happen, where you could trick the system into spending pretty much double the money. You could go buy double the thing, and the system would have a real problem dealing with that in these cases. But this takes a ton of money to do an attack like that. Richard, do you have some other examples of smart contract attacks that you might want to talk about?
Yeah, I mean, a lot of this is that Solidity is a new thing for developers. I mean, it's been around for a while, but there's so many new developers getting into it and thinking, oh, I'm going to just become this developer. I one time made an HTML web page, and now I'm going to be this Solidity expert. And understanding the nuances of what the language is and what its technical limitations are, what its design issues are, is really important. You were talking earlier about the decimal problem, where you can't have decimals; you just have integers that are positive. And the problem with that is that when Solidity was designed, I think they fixed this in a more recent version, but you could just, if you had a zero balance and they didn't check to make sure that the balance was zero, if you subtracted one, you'd now essentially have infinity because of a buffer underflow or buffer overflow if you were trying to do the opposite of that, where the number, if you added one to the maximum number, would just go to zero again. And so there's a lot of pitfalls here when you're developing Solidity. And this is why we see so many issues in the world today.
Absolutely. Yeah. And, this reminds me now, as you're talking about some of this, that there's attacks such as people think that random number generation on chain, you can't really generate random numbers on the chain. It has to be predictable, because all the people running the blockchain, all the nodes out there on the network, have to be able to validate the data. And if one of them could generate a random number, well, the other ones would not be able to regenerate that. They wouldn't generate the same random number if it was truly random, right? It has to be predictable in some sense. And people would make lottery systems, right? Where now if this random number that I'm putting on the chain matches this other number, then you're going to get paid, right? And the problem with that is that people can play these random number generation systems. Like they can actually on their node run through the transaction beforehand and say, oh, this one's going to lose, I'm not going to buy in. And they can keep doing that, and eventually they're going to get a hit where they do win the lottery. And it's because the system that they're on generated a random number in a predictable way, and now they know what the result is going to be, so they can submit the transactions. So these aren't things where we're actually being hacked per se, like they're taking the money out, but they're just taking advantage of the predictability of the system. And they call this like entropy illusion, where you think that you're going to be able to introduce all this entropy and this chaos and this randomness, and you really cannot in the blockchain. Now, the Ethereum 2.0 is going to solve this, but they're going to use an external service to do this. And once that random number is generated, they pull it into the data that goes on chain, and that's what all the nodes will play back. So it's like an external thing that's volunteering a random number, and this will help a lot with kind of random number hacks and things like that.
Yeah, and I'm sure that we could talk about this for quite a while. I mean, there's so many attacks and issues and hacks and problems for new developers, pitfalls that they fall into. So it's a pretty scary world out there. If you're looking to become a Solidity engineer, it's going to take some time, and definitely make sure that you're testing your code to exhaustion.
Yeah, sounds like it. Also, I mean, you guys are talking about the risks of being an engineer, but then also it sounds like consumers face equal risks. So what should consumers be careful of when interacting with smart contracts and just vetting them for safety, I guess?
Everything.
Okay.
Yeah. Really, if you don't understand a smart contract, you don't know what it's going to do. And people say, oh, it's open, you can go and read it and understand it. But if that were true, then the DAO hack wouldn't have happened. Vitalik himself was one of the engineers on the DAO, and I think he is the one that wrote those 2 lines and could have moved the subtraction line below the block of code that did the contract call and stop that attack. So even experts, people that wrote the language, still find themselves hitting these kinds of pitfalls. And that's why you test ad nauseum, and you make sure that those things are checked for.
Exactly. Yeah, and it is very hard. I mean, even as somebody who understands the code and can sit down and read it, just like Richard was saying, the order of those lines, I don't know how many people in a code review would have picked that up, let alone if I was off reading somebody else's code and, I'm supposed to extract all this knowledge. And then let's talk about the masses who just don't understand code or Solidity per se, and then, code in general. So with all of that, it's very, very hard to know if something's safe. And even if it is assumed safe, one of the things, I will look at the code, I will look at the contracts, but the biggest thing I do is I go to the communities before I get into a project. What is this community doing? Do they seem like they're genuine? Do they seem like they're trying to do the right thing? None of this is financial advice, right? But getting to know the management of the team and what they're, who they are and what they're doing has been a huge indicator to me. And even if you find a good community, good people, it sounds like they're doing everything right, and there's a lot of people using it, generally, if there was going to be a hack, you would have seen it at some point like that. But then somebody may discover a very nuanced attack, right? Something that nobody knew about that was completely hidden or not obvious to anybody, and that could come later. So there is this possibility that down the road, even in a good project that's well managed, something can be discovered. The beauty of these kinds of things is that they're normally managed by a team. And let's say that something like that happened, there are ways to recover some of these things. If the team wants to represent something that you own or that you had and they got hacked, they can sometimes regenerate that and give you back those things. Like, let's say it was an NFT and a bad contract. If something happened and somebody got a hold of those NFTs, they could shut down that project, maybe shut down that contract and regenerate it with the bug fix. Or, if it's an upgradable contract, they might be able to actually upgrade it and submit a fix in that way. And so all of this, it's just very hard for anyone, even if you are well versed in Solidity code, to look at these contracts and understand them. They do have audits.
Yeah. Yep, I was just going to say that. That's why audits are so prevalent. And there's some huge audit companies out there like Certic, and there's some other ones. And I think that we're actually going to be covering that in the next topic, right, Carla?
Right. I think Sieg's going to kick us off, but I might as well do it since you called on me.
Yeah, what is that, right, Carla?
Yeah, what's an audit?
Yeah. So an audit is where they'll take a smart contract. And they, I used to think that they would look at the code. And when you read through these reports, they don't look at too much of the code. When you read through the actual audit reports, and these are available on Etherscan. If somebody has had an audit done, Certic or some other company has done it, somebody's done an audit for you, you can go in and look at that report if it's been uploaded to Etherscan. You click on it, read through it. And most of what happens in there, they do put some notes in there about, hey, we saw that you're trying to do a random number thing. This isn't, going to work. So they do look at the code, I should say, but they don't go through, as I was saying earlier, and evaluate your intent. Like, what was this supposed to do? What are the pitfalls? How can somebody hack this and then verify that your contract is immune to those kinds of attacks? They don't do that. What they do is they look at it and they go, hey, so let's go back to the example we used earlier, right? We had the 2 lines of code. The order of those mattered. What the checks do now is they make sure that you're updating your state before you do external calls or before you do other things. In other words, all the state variables, so the balances and everything, have to be updated at the top. And they wrote software. There's a team out there that wrote software that does these checks to make sure that that line of code is on top. So if anybody wrote a contract that had the vulnerability that was exploited for the DAO hack, this code that we run I take that smart contract, that text file I generate, and I put it into this program, and it validates that. It looks at all that code and says, this has these vulnerabilities on these 2 lines. You need to fix this. Change the order of those lines now. So every time that we find something that can programmatically be detected and can be put into this automated system, this is what these audits are doing. Even these really advanced big companies that are doing audits, 99% of what they do comes from this project where they are analyzing the code and the Solidity code, and as it's been compiled, we evaluate that bytecode that comes out. All of that tells us a story of, do you have known vulnerabilities or things that were in your code that can be exploited? And if so, it points out the lines of code and we have to go fix them. But like I said earlier, they just don't do a good job of figuring out intent. Maybe you got your lines of code right now, but you forgot to put on the withdraw function. You forgot to put on a check that only the owner can do that. That's something these audit programs cannot tell you. And anybody in the world, as soon as that contract is uploaded and it gains some money, it has some crypto in it, anyone in the world can go withdraw it because you forgot to put on that is owner check. And no audit system in the world would catch that I know of.
Except for that secret one you're working on. That's behind the scenes right now.
That's the one we don't talk about. We don't talk about, Bruno.
Yeah, there's some interesting stuff coming down the pike that we'll be talking about in future podcasts. But right now, let's move on.
So briefly, we did talk about audits. How do you get an audit? You go to these people, you'll look online, maybe do a Google result. What are the benefits of an audit? It can help check in on some of it. But how can users be safer when using smart contracts? Is probably the question that I would have to have at this case, right? Because there's audits, there's things like that. I want to know how I can be safer, how I can protect myself when I'm walking around this space.
Yeah, and I want to answer one of the previous comments you just made as well. How do you get an audit? I've actually requested an audit before, and the process was pretty funny. They had some random guy message me on Telegram. He wanted me to attach the smart contract on Telegram and gave me some address to send a stupid amount of Ethereum to in order to do this audit. And that's essentially the random flow in today's world sometimes. But yeah, for consumers being safer using smart contracts, I mean, it's good right now in today's world with the limitations that exist. It's good to do what Nick said before, which is check in with the community, see what other people are saying about the code, maybe read through what the audit company said about the code, and just try to, what they try to do is they try to say, here's what the smart contract does, and here's the bad things that it doesn't do. That still doesn't mean, you're protected against everything, but this is Web3.
Yeah, I think it's, you make a good point that it's a new system, right? And it's still in its infancy. And so people I think, get really scared because we're seeing a bunch of negative results all the time. And people are talking about all these hacks that are happening, but there's so much money involved, right? There's trillions of dollars here or hundreds of billions of dollars available here. If people could hack that all the time, they'd be taking advantage of that. And we do see hacks, but they're not all the time. And what where we're at right now is we're working with a system that's still very much in its infancy. And as blockchain technology and the smart contract code starts to mature, we will see more and more stability coming out. And they're developing standards. Everything has standard. ERC20, ERC721. These are the tokens. These are the NFTs. All these standards are chunks of Solidity code that are provided to the developers just to say, look, we know this is good. We've tested it. We've vetted it. We've done the best job we can. And we know, as far as we know, there are no bugs in this code. Use it. And then you can, just on top of that, you can bolt on the slight modifications you want. And so this is the kind of thing that this is just starting. So as this continues to grow, full-blown applications are going to be available, not probably as a standard, but as off-the-shelf code that we can use that is known to work in 100 different projects. At that point, things will become much more reliable. So I would say don't be discouraged by any of the hacks or the vulnerabilities or the inability to vet some of these things. As long as the community is supporting the project and no known hacks have happened or there's a huge amount of money involved in this system, you know that people with a lot more money than us have looked at it and vetted these systems and have done their due diligence because they have a lot more to lose. And they're doing their best job to make sure that they don't lose that. And, as the people who are kind of the end users and the retail users of crypto, our best approach here is generally probably to look at what the smart money's doing. What are the people with the big money doing? What are the contracts that they're using? If they are using it, then you're probably good to go. If you're looking at something that you've seen 5 transactions on and nobody's talking about it, nobody knows about it, I probably would not execute a transaction on that contract because I just don't understand enough about it. There's not enough evidence for me to say this is probably safe.
Right. Well, it also sounds like these contracts are not infallible. So in the occasion that one fails, what happens? Like, what does that mean for the consumer? And then what does that mean for the company or the person who coded that contract?
Yeah, and this happens. We see this with all kinds of projects, and typically the solution that is come up with most normally is a either project relaunch or a project fork with an undo of that bad event. In fact, this model was probably created by Ethereum when they had that DAO hack with Ethereum Classic. I'm not sure if any blockchain projects had done this before. It's possible they had done this on Ethereum before, but essentially that's typically the solution that's grabbed first.
Thank you so much, Richard and Nick, for talking to us, answering some questions. Now would be a great opportunity just to talk about any personal experiences that you've had with smart contracts, anything that you've had, anything you can share with us. It would be greatly appreciated. I know from a non-developer standpoint, some of this might go over our heads, but just kind of, shooting the talk. Try not to curse here.
Yeah, I've got a fun story. One time I was called on a Friday night after, being out with some friends, and there was a contract that desperately needed to do a reboot. And so they needed to airdrop to only about 1,200 customers. And it happened to be a night where, Ethereum network was semi-congested, and an airdrop to 1,200 customers to get a new token into their wallets ended up costing the company about $35,000. So it can be quite expensive to use the Ethereum network, and we don't see a relief in that coming, which begs the question as to what's next in Web 3 or Web 5 or Web 1 million or whatever they come up with next.
I think that would be another good topic to discuss in the future is why is it still so expensive? Like what's up with layers, stuff like that. But I think that's for another time. So I appreciate you bringing that up right now though, because that's a really good topic of discussion. Moving over to Nick as well. Do you happen to have any stories off the top of your head that you could share with us? It might not be as fun as Richard's, but you got to give an earnest attempt, right?
Yeah, for sure. No, I remember when I first started using smart contracts, and I could send Ethereum and money between users with this extension called MetaMask that I had installed in my browser, and I started playing around with that. I had always used like Coinbase centralized exchanges when I first started in crypto, and then I kind of moved into this MetaMask thing because it let me interact with these applications. And I really was blown away once I realized what that really meant. And it just kind of opened my eyes because you could authenticate with this decentralized system, and that became your login. And now all of a sudden you're opening up this door where I can go to any website anywhere and be identified, but nobody knows who I really am. They just know that this is a user 123, right? It's like your address. And once I saw that, and not just that, but that you can pay for services online right there at the click of a button, and it's fully integrated with anyone in like 3 lines of code. It just was mind-blowing to me. So that was like my first experience. Like once I started using them and like interacting with these things, it just really opened up my mind to what the future of this has. And I just, that experience still, when I go back to it, just makes me feel like when I first started using the internet, right? And it's like this is little itty bitty seeds that are being planted right now. And there's going to be a forest soon, right? But it's going to take time to build that and time for it to grow. But it is very exciting because I can just see all this potential where you don't need third-party integration. Like building a payment system into a website used to be a huge engineering task. You'd need multiple people, or you'd have to pay some service 5% of your income in order to get integrated if you wanted something that simple. And now it's just part of the blockchain. It's it's right there. You just click a button. Somebody has to add 3 lines of code. They've got both login, they've got the ability to pay for services, transact, and I think it's just really going to change the way things are done on the internet if it doesn't completely change the way the internet operates. And so that all is very exciting to me, and I wanted to share that first experience. I think that was just so cool, and that's why I'm working on blockchain now. It just really got me excited about the thing.
Yeah, now when you want to order your Starbucks, you just interact with their smart contract and pay $100 in ETH, and then you get your $17 coffee.
That's it. Yeah. You get NFTs every time you buy a coffee. Serial number. No.
With all the ingredients that went into it, the whole shebang. Honestly, Nick, thank you so much for sharing your experience. That was really sweet of you. I think we're running up our time here. Greatly appreciate you coming in as a guest on the show, Nick. Carla, do you have any words, any sages advice?
I don't usually have sages' advice.
Well, we know you don't have sage advice.
Yeah, but I have sages advice.
But do you have someone else's?
I do have someone else's advice. Do your own research before choosing what to invest in, because this is not financial advice.
That was great. Thank you so much, Carla. This has been PyxelChats. We just finished talking to our guests, Nick and Richard. Thank you so much. Carla, let's say goodbye to the people at home. Thank you so much for coming. We hope you have a great day.
Until next time, see you.